Assalamualaikum warahmatullahi wabarakatuh. Introduce us from Group 4. My name is Fitri Manasution. NIM 23029015. Studi Program Mathematics Education Class B. 3 dimensions. Session 1. 1. Introduction to 3 dimensions. A. 3 dimensions is mathematical concept that describe 3 dimension space consisting of length, width, and height. The main difference, length, width, and height, the main between 3 dimensions and 2 dimensions is the addition of the height dimensions. B. Example of object in 3 dimensions is in everyday life include cubes, sprites, primes, pyramid, and buildings. 2. Graphic representations in 3 dimensions. A. 3-dimensional Cartesian coordinates are a system used to represent the position of objects in 3-dimensional space. This system consists of 3 perpendicular axes: the x-axis, y-axis, z-axis. B. Points in 3 dimensions are represented by 3 coordinates x, y, z, where x represents the position axis and z represents the position on the y-axis, and z represents the position on the z-axis. Lines in 3 dimensions can be represented by 2 different points, while planes can be represented by 3 non-collinear points.
Hello everyone, my name is Priska Maharani. You can call me Priska with name 23029016 from the Mathematics Education Program Class B. I to explain the section 2, the number 1 vector in 3 dimensions. Part A, Introduction to 3-dimensional and vector notation. Vectors are quantities that have magnitude the direction. Vectors are usually represented by arrow or directed line segment. And like this example, the length of the arrow shows the z of the vector and the direction of the arrow shows the direction of the vector. And notation vector, we write vector with bold letter or by place arrow on them. The z or length of the vector is denoted by like this example. Vector 3-dimensional is a vector that has 3 axes, namely x, y, and z. Like this example, vector v is a component x, component y, and component z. Example, x equal 3, y equal 4, and z equal 1. And next, part B, vector operation in 3 dimensions. Number 1, addition of 3-dimension vector. Vector can be expressed in 2 forms, namely in column form or in row form. Column form and row form. column, and row. If two vector A with the component A1, A2, and 3, and vector B with the component B1, B3, B2, and B3. So, vector A plus vector B equals A1 plus B1 and A2 plus B2 and A3 plus B3. Like this example. And next, reduction of three-dimensional vector. If the vector A and vector B, so vector A minus vector B equals component A1 minus component B1 and component A2 minus the component B2 and component B A3 minus a component B3. And next, number 3, scalar multiplication with vector. The product vector are A1, A2, and A3, and with the scalar vector is and with the scalar vector C is defined as follows: C times vector A equal C times the component A1 and C times the A2 and C times A3. And number 2, distance and angle in 3 dimensions. And part A, introduction to the distance formula between 2 points in 3 dimensions. How to determine the distance between 2 points in 3 dimensions? The distance from point A, x1, y1, and z1 to point B, x2, y2, z2 is the distance between 2 points in 3 dimensions equal root x2 minus x1 in bracket square plus and y2 minus y1 in bracket square plus and z2 minus z1 in bracket square. And part B, introduction to the angle formula between two vectors in 3 dimensions. How to the angle formula between two vectors in 3-dimensional is, for example, vector A, x1, x3, x1, y1, and z1, and vector B the equals in x2, y2, and z2. So, to the angle formula between two vectors, cos theta equals vector A times vector B divided by the vector length A times vector length B. And sin theta equals root 1 minus cos theta. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is Hanifa Dinda. I am from the Mathematics Education Study Program, Class B, with NIM 2302919. I will explain about Session 3. Number 1. Life equation in 3 dimensions. A. In three-dimensional space, parametric equations describe the coordinates of a point in terms of one or more parameters. For example, a parametric equation for a point x, y, z could be written as x equals ft, y equals gt, and z equals ht, where t is the parameter. Symmetric equations express the relationship between the coordinates of points on a line without using a parameter. For a line in three-dimensional, the symmetric equation can be written as xo divided by a equals yo divided by b equals zo equals c, where xo, yo, zo is a point on the line and a, b, c is the direction vector of the line. B. Example of applying the line equation in 3 dimensions. A line passing through the point 1, 2, 3 with a direction vector 2, minus 1, 4 can be expressed as x minus 1 divided by 2 equals y minus 2 divided by minus 1 equals z minus 3 divided by 4. This equation provides a way to represent any point x, y, z on the line. Number 2. Plane equation in 3 dimensions. A. In 3 dimensions, general equations of planes can be expressed as ax plus by plus cz equals d, where a, b, and c are coefficients representing the plane's normal vector, and d is a constant. Parametric equation of the plane involve introducing two parameters, typically denoted as u and v. For example, a parametric representation of a plane could be r u v equals r o plus uv plus vw. Ro is a position vector to a point on the plane, and v and w are vectors parallel to the plane. The parameters u and v allow you to generate points across the plane. B. Example of applying plane equation in 3 dimensions. Let's consider a plane in 3 dimension space with the equation ax plus by plus c z equals d. This equation represents a plane with normal vector a, b, c, and a distance d from the origin. For instance, if we have the equation 2x minus 3y plus 4z equals 12, the normal vector is 2 minus 3, 4, and the plane is located at a distance of 12 units from the origin along these normal vectors. To check if a point, let's say 1, minus 2, 3, lies on this plane, you substitute the coordinates into the equation. Since the result is equal to 12, the right-hand side of the equation, the point lies on the plane.
Hi, I am Indah Purnamasari with name 23029127. I'm from Mathematics Education Class B. Geometric transformation in 3 dimensions. A. Introduction to translation, rotation, and dilatation transformation in 3 dimensions. Translation. Moving an object in 3 dimensions without changing its shape or orientation. Rotation. Rotating an object in 3 dimensions around a specific axis. Dilatation. Enlarging or shrinking an object in 3 dimensions by a certain scale factor. B. Examples of applying geometric transformation in 3 dimensions. In animation and computer graphics, geometric transformation are used to move and rotate objects in 3-dimensional space. In robotics, geometric transformation are used to control the movement of robots in 3-dimensional space. In 3D modeling, geometric transformation are used to change the position, rotation, and scale of objects in 3-dimensional space. Application of 3 dimension in real life. A. Examples of applying 3 dimension in architecture, product design, and technology. In architecture, 3 dimensions are used to design buildings and space, considering aspects of volume, shape, and layout. In product design, 3 dimensions are used to design products, taking into account aesthetics, ergonomics, and functionality. In technology, 3 dimensions are used in modeling and simulation to develop more efficient and effective products and systems. B. Discussion on the benefits of understanding 3 dimensions in everyday life. Understanding 3 dimensions allows us to visualize and comprehend objects and space in everyday life. Understanding 3 dimensions enables us to design and develop better and more efficient products, buildings, and systems.